In the previous sessions, we have looked at, or rather we have used Cardano's method for solving the cubic equation. Now, let's look at it much more formally. If we take the general equation of a cubic to be a sub naught x cube plus 3a sub 1 x square plus 3a sub 2 x plus a sub 3 equal to 0. Now, immediately the question arises, why, or how can we take this as a general form of a cubic? So here, note that the factor 3 in the second and third terms can be factored out from the corresponding coefficients of the given cubic equation. For example, let's say we are given a cubic equation 2x cube minus 30x square plus 162x minus 350 equal to 0. Now, how do we convert this into this form? We factor out 3 from the second and third term. So we get 2x cube plus, because here plus is required, plus 3 times minus 10 x square plus 3 times 54x minus 350 equal to 0. So here 3, 3, no issues. So now here a sub naught is equal to 2. A sub 1 is equal to minus 10. A sub 2 is equal to 54. A sub 3 is equal to minus 3. And that is how we get this form. Now, once we have done that, or once we have that given equation, after we write it in this form, we depress the cubic polynomial. What this means, we have already seen in our previous seconds. So the depressed cubic would be of this form: z cube plus 3hz plus g is equal to 0. So while we are depressing it, or in the process of depressing the cubic, we obtain the following expressions. Z is equal to a sub naught x plus a1, g is equal to a sub naught square times a sub 3 minus 3a sub naught times a sub 1 times a sub 2 plus 2a sub 1 cube. And finally, h is equal to a sub naught times a sub 2 minus a sub 1 square. The process of depressing the cubic we have seen in our previous session. Now, taking z is equal to cube root of u plus cube root of v. Again, how this u and v come about, we have seen in our previous sessions. Now, taking cube on both sides, we get z cube is equal to the cube of cube root of u plus cube root of v. Expanding it, we get z cube is equal to, now cube of cube root of u is u, cube of cube root of v is v, and in between we have 3 times cube root of u times cube root of v times cube root of u plus cube root of v. This is nothing but the binomial expansion of a cubic. Now, z cube is equal to u plus v plus 3 times cube root of u times cube root of v times z. Where did this z come? Because cube root of u plus cube root of v is z. Now, rearranging this, we get z cube minus 3 times cube root of u times cube root of v z minus u plus v is equal to 0. This is of the form z cube plus 3hz plus g equal to 0. We have z cube plus 3hz plus g, where h is equal to minus 3 cube root of u times cube root of v, which implies minus h is equal to cube root of u times cube root of v. If we take the cube on both sides, we get minus h cube is equal to u times v. So we have got product of two quantities u, v. Now g is equal to minus u plus v. If we do the comparison of these two equations, which implies minus g is equal to u plus v. So now we have the sum of the same two quantities u and v. So we can form a quadratic equation using the product and sum of two quantities whose roots are u and v. So we get this quadratic in t. Why we are not taking x is because x is already been used up. So t square plus gt minus h cube equal to 0. Using the quadratic formula, we can solve for t. T is equal to minus g plus or minus square root of g square minus 4 times 1 times minus h cube divided by 2 times 1. So t is equal to minus g plus or minus square root of g square plus 4h cube, the whole thing divided by 2. And we know the roots are u and v. So t is equal to u and v. Now, cube root of u and cube root of v have 3 values each. There are 3 cube roots of u. There are 3 cube roots of v. Therefore, there are total 9 possibilities. But a cubic polynomial equation has exactly 3 roots. So we have to find just the 3 of those 9 possibilities. For that, we use another fact that we know. That is, cube root of u times cube root of v is equal to minus h. So let's now use this to figure out which of those 9 are the relevant ones. So now this implies that cube root of v is equal to minus h by cube root of u. The first root z sub 1 is equal to the cube root of u plus cube root of v itself, which can also be written as cube root of u minus h by cube root of u. Now for the second root of the depressed cubic, we take z2 is equal to cube root of u plus cube root of v, but then we multiply these two by omega. Cube root of u, we multiply it with omega, and cube root of v, we convert it into minus h by cube root of u, and in the denominator, we multiply it by omega. Okay, now we multiply and divide by omega square this term, h by omega times cube root of u. So we get omega times cube root of u minus omega square times h divided by omega cube times cube root of u. Now omega cube is nothing but 1. So that disappears. And we have z2 is equal to omega times cube root of u minus omega square times h divided by cube root of u. Now h is what? H is cube root of u times cube root of v. So we do the substitution. Cube root of u and cube root of u gets cancelled, and we end up with omega times cube root of u plus omega square times cube root of v. So this is our second root of the reduced cubic or the depressed cubic. Now we look at the third root of the depressed cubic. Starting with the same, z3 is equal to cube root of u plus cube root of v. Now we multiply by omega square. What happens then? Z3 is equal to omega square times cube root of u minus, we multiply and divide by omega. So we get omega times h divided by omega cube times cube root of u. Again, omega cube is equal to 1. So it disappears. And we have omega square times cube root of u minus omega divided by cube root of u, and we do the substitution for h, that is times minus cube root of v times cube root of u. Cube root of u cancels, minus minus plus, so we get z sub 3 is equal to omega square times cube root of u plus omega times cube root of v. So we have got the three roots of the depressed cubic. Now, we can get the three roots of the original equation using z is equal to a sub naught x plus a sub 1, which can be rearranged for x. So x is equal to z minus a sub 1 divided by a sub naught. So we get the first root alpha 1 is equal to z sub 1 minus a sub 1 divided by a sub naught. Second root alpha sub 2 is equal to z2 minus a sub 1 by a sub 0. And the third root alpha sub 3 is equal to z sub 3 minus a sub 1 divided by a sub naught. Let me briefly explain what exactly is happening with this omega business. There are three cube roots of 1. That is 1, 1, omega and omega square, where omega is equal to minus 1 plus I root 3 divided by 2, and omega square is equal to minus 1 minus I root 3 by 2. And omega cube is equal to 1, or we can say omega times omega square is equal to 1. Now, using these identities together with the condition that cube root of u times cube root of v is equal to minus h, we obtain the three valid roots of the depressed cubic. The key point is that omega times omega square is equal to 1. So multiplying cube root of u times cube root of v by omega times omega square does not change its value. This is the key point that we are utilizing here. So this is the Cardano's method. Very nice techniques that has been used. That's it for now. Bye.